All right, let's talk about statistics. So first thing we'll talk about is some basic terminology, sampling, frequency distributions, and graphs. So first we'll start with sampling. Before we do that, we need to know a few definitions. So what is meant by statistics? Well, it's a method of collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. We're going to talk about a population. That's the set containing all the people or objects whose properties are to be described and analyzed by the data collector. In other words, it's the set of all things that we want to know about. A sample is a subset or a subgroup of the population. A random sample is even better because if we pick and choose our sample, we can have biases. But if we have a random sample, then that's a better understanding of the population. And that is a sample obtained in such a way that every element of the population has an equal chance of being selected. So, here's an example. You're tasked with surveying students at LSU with their preference for the location of a new parking lot. Which of the following is the best way to do the sample? So we have three choices here. Survey students at the student union between 10 and noon on a Monday. Survey a random sample of students in fraternities and sororities. Survey a random sample of students who attend classes on campus through email. Let's start with the ones that are wrong. I think the most obvious wrong answer is B, because if we only ask the fraternities and sororities, obviously they'll choose something that's closer to their housing. Then usually it comes down to A or C. Sometimes students will guess that it is A, but it is not. The reason why is if we choose students at the student union between 10 and noon, well, what about the students who are in class from 10 to noon? Or maybe they don't even come to campus until after 3 o'clock. Or they don't even come to campus on Mondays. So that one's an issue. But if you sample the students by email randomly, then you have a better chance of getting a random sample. All right, so that said, now we can start looking at some data. This first situation, this is the number of hours that the students in a small Math 1029 class got the night before a particular class. Okay, and so we're going to talk about frequency distribution. So we're going to, from now on, we're going to start taking data and we're going to be organizing it. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's another row of 10, so that's 20 items. So our data set, our sample space is 20. Okay. So let's write that. Our sample space, or population, is 20. So usually what we do is we write N equals 20. N is our population. All right, so each entry or piece of data is called a data item. So that's a data item, that's a data item, that's a data item, etc. You also will notice that some things occur more than once, like these 7s occur 3 times, or 10 occurs twice. So what we might say is that the frequency of 10 is 2. That's going to come into play later on. Okay? And what I mean by that is when we have sets of data, we can present the data using frequency distribution tables. In a frequency distribution table, we have 2 columns. The left column is going to be the data values, generally listed smallest to largest. And then the right column is going to be the frequency, which is the number of times it occurs. So that's what we're going to do here. Now what I've done is I have recopied the data set from our example. Instead of 2 rows, so I could squeeze my table in, we have basically 2.5 rows, but it's 8, 10, 6, 4, 5. We end with 8, 4, 3. So it's the same set of data. So I'm going to move this page. We have our data set, and we have our table created. What we're going to do is we're going to fill in the table. Now, it doesn't have anything for us. We've labeled number of hours of sleep, number of students with a frequency. Sometimes it'll just label the right side as frequency. Sometimes it'll say number of students or number of things. So I guess we have to find the smallest numbers first. So it looks like 3 is the smallest. Okay. Generally, we would do all, in this case, since the numbers are very small, 3, I think the largest is 10, we would just list out 3, 4, 5, 6, 7, 8, 9, 10. If we have a larger data set, which we'll see in our next example, and the data set kind of is more spread out, then we would do something different. But in this case, we only have 20 items. The numbers are relatively close together. The smallest one is 3, so the largest one is 10. I just listed them all. Now, what we're going to do is put the frequency. So how many times does 3 show up? 3 shows up twice. I recommend circling or highlighting or underlining the numbers as you go along. We know at the end of the day, when we finish this, we should have a total of 20. Okay, we already know that. 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19, 20. So we know we have 20. And as I go through, I like to highlight or circle so I know what I've covered, especially when we have a larger data set. 4, we got 1, 2, 3, 4, 5. Usually as I go through, I highlight 1, 2, 3, 4, 5. All right, let's do that again. For 5s, we got 1, 2, 3. I guess this method I'm checking myself. 1, 2, 3. Number of 6s, 1, 2. Number of 7s, there's 3 of them, 1, 2, 3. And you see, as I highlight, it becomes easier and easier to find the next number. And if I didn't count it, I didn't highlight it, then I could say, oh, well, let me see. Did I get all the 7s? 1, 2, 3, okay. The number of 8s, 1, 2, 3. And then we don't have any 9s, right? We just have 2 10s. We have no 9s, so we just say 0. And then for 10, we put 2. Now, I would recommend taking that stuff and then adding those numbers. 2 plus 5 plus 3 plus 2 plus 3. Oops. Oh. I don't know what that was. I think I pulled up an old calculation. 3 plus 2 plus 3 plus 3 plus 0 plus 2, 20. So I might do that calculation twice just to make sure I got everything. So that is a frequency distribution table with this set of data. Now, I also have to go on to say that, sometimes if we have a larger data set, we might not have the space to write every single possible integer, 3, 4, 5, 6. What if it ranged from 3 to 57? I mean, I know that doesn't make sense in this example, but what if our data set was like 3 to 57? I don't think I need to do 3, 4, 5, 6, all the way to 57. So we introduce a grouped frequency distribution, and that's basically used when we have a lot of data items, like we will in our next example. So if you have a lot of data entries or there's not a lot of repeating items, then you might choose to do a group distribution, group frequency distribution, and that separates them into classes or groups. Okay, so when we do that, the leftmost number is going to be the lower class limit, the rightmost number is going to be the upper class limit. This is the key. This is kind of tricky. The difference between any two consecutive lower class or upper class limits is the class width. Often the questions will ask, what is the class width, or the class width is. So we're going to look at that in our next example. So notice here we've got the presidents, the ages of the presidents at the time they were inaugurated. So that's like 40-something, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1, 2, 3, 4, 5, 45, 46. So we have a total of 46 presidents. This is as of 2022. So it says to use 41 to 45 for the first class. Okay. For some, it's obvious what the next class will be. But let's first diagnose or figure out what 41 to 45 includes. I don't have a lot of space, so I'm going to do it up here. 41 to 45 are the integers 41, 42, 43, 44, 45. 1, 2, 3, 4, 5. So our class width is 5. I'm going to show you another way to do that. Oh, that's messy. I'm going to put my next one down here, but yeah, the class width is 5. 1, 2, 3, 4, 5. So my next one should have 5 as well. 46, 47, 48, 49, 50. If you already knew that, good for you. That's kind of a tricky one for students. I mean, these numbers, when it's 5 like this, or if it was 10, that's kind of easy to see. But I also want to show you that according to this, the class width is found by finding this number minus this number. So 50 minus 45 is 5, or 46 minus 41 is 5. Okay, so your class width could also have been found by doing 50 minus 45, which is 5, or 46 minus 41, which is also 5. For me, and usually when I describe it in class, I usually like to write out the integers, and that kind of helps solidify it, because the temptation is to say 50 minus 46 is 4, or 45 minus 41 is 4, but that's incorrect. All right, so you probably see the pattern. 51 to 56, 51 to 55. 56 to 60. 61 to 65, 66 to 70, 71 to 75, 76 to 80. Okay, and I've got it spaced out to where this is enough. The largest number was 78, and so this covers it. Okay. All right, so what we're going to do is essentially copy what we just did here, where the difference was we were picking out precise numbers. But here we have to find class width and find all the numbers that satisfy 41 to 45 inclusive. So that's 41, 2, 3, 4, 5. All right. I'll warn you, I usually make some mistake somewhere. We'll catch it, and I'll show you how to fix it if we do. So, 41 to 45. That's kind of easy because I'm looking for all the 40s. There's no 40s up top. There's a 48 down here, but that's for the next one. That's a 40, but that's for the next one. That's for the next one. All right, 42, that's 1. 43, that's 2. All right, I believe that's it. I think it's just the 2 of them. Okay, so I like to put this number a little bit to the left in case I make a mistake. I can always come back and scratch that out and put the correct one. All right, let's see here. 46 to 50, I kind of started looking at my other 40s. But let's see. Oh, here's another one. None up top, so 1, 2, 3, 4, 5, 6, 7. Again, if I made a mistake, I can catch it. I'll just scratch it out and add 1 to it. Okay, so I should have all the 40s done. Should have no more 40s up top, second, third, fourth. All right, now we move on to the 50s. I'm looking just for 50. Oh, that's usually where my mistake is. It's 46 to 50, so let's see if there are any 50s, and there it is. Let me double check this. I warned you, I said I was going to make a mistake. And that's usually the mistake. All right, so there's only 150 that I'm seeing. So I'm going to add that to my tally, scratch out that 87 and put an 8. All right, let's try not to make that mistake again. 51 to 55. So we have 54, that's 1, 2, I'll come back to that. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Like I said, I knew I made a mistake. There's another 50. With so many data set or so many data items, it's a good chance you're going to make a mistake, and that's why I like to highlight. So let me see if I got all my 51 to 55s. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the further down this list of 46 I go, it should get better because I have fewer and fewer to look at. So the next one's going to be 56 to 60. So I'll remind myself to include this 60. Any other 60s? No. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, I think that's it. All right, 61 to 65. 1, 2, 3, 4, 5, 6, 7. All right. 66 to 70. 1, 2, 3. All right. And then we've got one number left. We've got two classes. This is 71 to 75. There's none. That's okay. And then 78 is 1. Now, let's see. How do I know if I got them all? We're going to add up all of these numbers. So 2 plus 9 plus 15 plus 9 plus 7 plus 3 plus 0 plus 1, 46. Okay. I might double check that if this was a test or something. But generally, the questions, you'll see some that are real long, but most of them, if it wants you to do this, the entire question is just that. Fill out the table. So that brings us up to, and now I can see my answer should be correct. 2, 9, 15, 9, 7, 301. I didn't want to cheat and go to that page. I wanted to figure the question out ourselves, but now I know it's correct. So in the next page, what can we do with these frequency tables? Well, we can make graphs. And then a lot of times in the homework, we have to make graphs and interpret graphs. Fortunately, if you have to make the graph, it's going to be multiple choice. And you can use a little bit of process of elimination to get through those. But I think it's important to understand how the graphs are made. So, here we go. Once we have our group frequency distribution or frequency distribution, we can make a table. We have our table. We can make a histogram, a frequency polygon, a pie chart, etc. We're only going to create a histogram and a frequency polygon in this video, but generally for any of the others, it's usually easy to pick out. So what is the difference? Well, a histogram looks like a bar graph. In fact, some people call it a bar graph, but technically it's not. In a histogram, a series of rectangles or bars whose heights represent the frequencies are placed adjacent to each other, whereas in a bar graph, there's some space. The horizontal axis represents the data item or the class width. So, let's see. On these, I will put, so our frequency is going to be up here. I'll do frequency over here. I'm not putting it right beside the graph because I'll put numbers. And this will be our class width, or frequency, no, not frequency, class width, or age when inaugurated. So we could call it either 1. And the book will do either or, and you just have to know it's the same idea. Inaugurated. It's a hard word to spell. Okay. All right, back up here. So what we're going to do is we're going to make our histogram first, and then I'm going to use our histogram to make the frequency polygon. And I'm actually going to kind of work them together at the same time. Okay. So let's look at our There's a flickering on my end. I wasn't sure if it was on your end. All right, so let's go ahead and make our group frequency distribution. With our group frequency distribution table, let's make our histogram. All right, so here's what we got to do. I don't have a lot of space down here, but I am going to let, let's see, I'll do it this way. for the sake of my frequency polygon, and I want these to look the same, I'm going to do these the following. We got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I think what I'm going to do is I'm going to start my first class here. 2, 3, 4, 5, 6, 7, 8. Because for my frequency polygon, we have something at the very end that we tie down, and I want to leave space for that. So what number goes here? It's the midpoint that goes here. How do we find the midpoint? So finding the midpoint. All right, the easiest thing to do is just to do 41, 42, 43, 44, 45. The midpoint of this guy is that. So that's what goes here. 43. Now I'm going to continue to do this. You're going to see a pattern. The next one is 46, 47, 48, 49, 50. The midpoint of that class is 48. And so I don't think I need to show all of those. I think you can kind of see the pattern. 43, 48, 53, 58, 63, 68, 73. And on the ends, I'm going to tie down later on. It's not here, but the imaginary... Am I missing something? Oh, I have one more. There you go. About to say. And this would be 78. Sorry. So if I had a class width that's lower, then I would do 58 here. And then if I had one higher, it would be 83. I'm going to write those in red. We're not really using those for my histogram, but I will use them for my frequency polygon. So let's go ahead and just put these numbers. I'll keep them the same. So that's 58 here, 43, 48, 53, 58, 63, 68, 73, 78, and then we had our extras that I'll talk about in a little bit, 83 and 58. Okay. So our frequency is next, and I'm going to keep these the same. Let's see, can I do 15? Can I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? No, that doesn't work. What about 2? 2, 4, 6, 8, 10, 12, 14, 16. That works. So I'm going to let each of these be 2. And then you're wondering, what if we have an odd number like 9? Well, if we have an odd number, we just have to go as close to the middle as possible. Okay? So 2, 4, 6, 8, 10, 12, 14, 16. What I do is I will go through and I will find the midpoint, starting with 43, not the midpoint. I find the frequency and I put a dot there. Okay, so the first one is 2. I'm going to do it for both of these. So I'm going to go through, I'm going to put my dots first, and then I'll go and I'll do a histogram or a frequency polygon. All right, the next one is 9. That would be as much in the middle here as possible. The next one is 15. The next one is 9. That's easy. That would be 56 to 60. The next one is 7. That is 61 to 65. The next one is 3. Lots of odd ones. 66 to 60. Okay, so 3 is next. And then 0, that's very easy. And then 1 here. So I'm plotting the same thing. Some teachers will have actually plot one of these and they draw the histogram, and on top of that they put the frequency polygon. But I don't want to be confusing, if that's possibly confusing. So for my histogram, what you do is you go about halfway, because what this is this is 41 to 45. Okay, I'm going to do this again. We'll do it here. So what we're doing is we're making our histogram. The dot that we plotted, that's like the midpoint of the bar. And if you want to color those in, you can. I'm going to leave them uncovered, I think. Uncolored. Maybe darken some of these lines. All right, so that's a histogram. Probably should have used a straight edge, but I feel like that would have taken too much time. For my frequency polygon, what you're doing, let's talk about that real quick. The frequency polygon is the difference is we're going to draw straight lines connecting each of these vertices, each of these points, and then we tie down the ends, and that's why I put the extras. Okay, so here I will use thought I had my straight edge close by, I don't, so we will just use this deck of cards as a straight edge. So we're going to tie down here, and then the rest of these are just straight lines. And it makes a polygon. Polygon just means a geometric shape of a certain amount of sides. It usually looks more like a mountain. And then we tie it down at the end. So there's our frequency polygon on the right and our histogram on the left. All right, one last thing we need to do in this section is creating a stem and leaf plot. So we have to understand what is meant by a stem and leaf plot. Basically, it'll look similar to a histogram, but the way we're going to do a stem and leaf plot is just another way to visualize the data. We will have our column for stem, and then I'm going to do this because I know what's going to happen. I'm going to try to squeeze this in as far to the left as possible. And then on the other column, we have leaves. Leaves. So this is the ones place. So like in the number 46, it's 6 is the ones place, 4 is the tens place. And this is everything else. Everything else. Okay. I have something that's better as a straight edge. I'll use that because I'm going to draw these lines across. So what goes here? Well, these are the ones placed. This is everything else. We are going to put these in the stems or the tens place in order. So the smallest number, this is again the presidents, the smallest number was 40-something, and the largest number was 78. We know that from earlier. So I'll go 4, 5, 6, 7, 8. Okay, so it's similar to the histogram, but we're doing tens place. We're not doing any other like class width. I guess our class width is basically tens. The nice thing about this is you do not have to put it in any sort of order, other than your stems need to be in order. But the rest of these do not. So I don't have to go and find the smallest 40 and then put that. You can go, you just start with 57, you put a 7. 61, you put a 1. And as I do this, I try to keep these in columns because that's going to show us this like length over here. All right, 57 twice. So I'm going to just draw 7 and another 7. If it happens multiple times, you just keep putting it. 58, 57. All right, 61 again. 54. We're going to have lots of 50s, by the way. 68, 51, 49, 64, 50, 48, 65, 52, 56, 46, 54, 49, 50, 47, 55, 55. By the way, I don't know if you're going to have to make too many stem and leaf plots. You do have to make some. But generally what we're going to be doing the rest of this chapter is interpreting or doing things with stem and leaf plots. So you have to be able to go really generally from here, the final stem and leaf plot, to understanding what it means with your data set. 54, 42, 51, 56, 55, 51, 54, 51, 60, 62. Trying to keep these in order. 43, 55, and we're almost done. 56, 61, 52, 69, 64, 46, 54, 47, 70, and 78. All right, so now we are done. And if you turn it sideways, it kind of looks like a histogram, is the idea. So you can see that the majority of the data from our data set are in the 50s. You could have probably guessed that, but that's one of the benefits. But like I said, be able to interpret stem and leaf plot, be able to go from here to here for the rest of the chapter.